Hello and welcome back to part 2 of my CNC router videos. In the first video I showed you how I built this machine. In this video I'm going to show you how to use it. We're going to use Arduino, Universal G-Code Sender, and Fusion 360 to build a couple parts. Let's get started. In the description below I've included 3 links that you'll need to get your CNC router table running. The first is for the Arduino software, the second is for the Universal G-Code Sender platform, and the third is the plugin for Fusion 360 that connects to Universal G-Code Sender. This is the first website. You'll want to click here where it says code and download zip, and you'll want to store that zip file with your other Arduino libraries. Yours might be in a different place, but mine are under Documents, Arduino, and Libraries, and here is the new file. After that, you'll need to go back into the Arduino IDE, and under Sketch, include Library, Add Zip File, and you want to navigate till you find your new file that you just downloaded. Once you've done that, you should be able to go back to the IDE, and under File, you can click on Examples, and you should see this new GRBL upload example. And this is all you have to do. Find your board and upload this to your board. You don't have to do anything else. This is the website to download the Universal G-Code Sender, but instead of downloading the zip here, you'll want to scroll down and get the nightly build version, which supposedly works better with Fusion 360. I got the Windows 64-bit because I have a Windows machine, but if you have a Mac or Linux, there's links as well. So download that and get that installed on your workstation. This is the website for the Fusion 360 Universal G-Code Sender plugin. Once again, you'll want to download and extract the zip file. Next, you'll want to crack open Fusion 360 and click on this Utilities button here, and then Add-ins, Scripts and Add-ins. And then click on the Add-ins tab here, and you should see UGS Fusion. You want to run it the first time, but I've already installed it, so I've clicked this Run on Startup. You'll want to do that so that it automatically runs each time you start up Fusion. Now, once all your manufacturing is set up in Fusion, which I will show you later in this video, you will export your G-code to UGS using this Post to UGS button right here. You will need the first time to put the location of your EXE for UGS. This happens to be where I've installed mine. Under Post to Use, you'll want grbl.cps. Click on this button here, and when you're ready to run a setup, you'll click on Setup, pick which setup, and hit Post. Before we get too far into Fusion, however, we want to set up our Universal G-Code Sender software. So open that up, and under Firmware, make sure you have GRBL. Under Port, find your Arduino that's connected, and make sure the baud rate is set to 115/200, and then click on this Connect. Once your Arduino has connected, click on Machine and then Setup Wizard, and then hit Next. We're not going to import settings, so just hit Next. This is where you check the polarity of your motors, if they're spinning in the right direction. Click on X plus and see if it's going the direction you want it to. In my case, it was not for X and Y, so I've clicked these reverse directions. My Z, however, was going in the correct direction. Once you're satisfied with that, click the Next button. And here's step 4 you might actually want to do before step 3 if you're using micro-stepping like I am. So in order to calculate these numbers, you need to know how far each lead screw advances with one turn. Some of mine are 5 millimeters, some are 4 millimeters. So with the micro-stepping that I have, these are the values that I need. If you use the same parts that I did, you'll want these values the same. So update these to 320, 400, and 400, and then hit Next. We're not using limit switches, at least I'm not on my machine, so I'm going to skip this step, which also disables the homing function. and the soft limits function. Click Finish, and it should store those values onto the Arduino. Now, what you want to do here is hit $, and then enter, and it should give you these values here. I would recommend that you copy and paste these in a file somewhere. These are your initial settings. And if you ever need to revert back to them, you'll want those here. Okay, up here in the upper left-hand corner, you'll see values for X, Y, and Z. There's a bigger number on top, smaller number on bottom. The smaller number on the bottom represents the location of the spindle as compared to the home position of the machine. And since we don't have limit switches on our machine, every time you reconnect the Arduino, it's going to think that it's in the home position. The number on top represents the spindle position in relationship to the part you're about to machine, and that's represented over here in this XY axis. So right now it thinks that it is right where it needs to be to start machining whatever part we're going to run. And I'll show you how to change those a little bit later. So down here you have your jog controller feature where you can change how much you want to move it. So we're going to go 2 inches in the X direction. Let's go 2 inches in the Y direction. And now you'll see that these have each moved 2 inches. Now, if you look up here in the machine menu under actions, you'll see the home machine is disabled, and that's because we do not have limit switches on this machine. But return to 0 is enabled, and if I click on that, you'll see that the machine will return to the part center orientation. Now, if you're running a project in millimeters rather than inches, you can simply go over here to the upper right-hand corner and click on this inch button, and it'll change your units back over here to millimeters. Now, if you want to test out your spindle, you could type down here M03 space S 12,000. 12,000 meaning we want 12,000 RPM, and if I hit the enter button, the spindle turns on. It's a little quiet, but I promise it is on. And if we type M05, it turns it back off. So you probably recognize this part from my last video. I cut this out using this 1/8 inch end mill. I'm going to show you how I set that up quickly here in Fusion 360. And then we'll do another part more step-by-step from scratch. Here in Fusion 360, we create setups that we export to the Universal G-Code Sender. So if I hit edit on this one here, you can see how I've set it up. You can see that I put about 1 inch of stock material all the way around my part and set my origin to here. You can change those over here. My stock, here's where I added 1 inch to each side. So if I change that to 0.5, for example, it would change here. Let me switch that back to 1 inch. Now within this setup, I have 2 different 2D contour operations. The first is for this inner pocket, and the second is for the exterior. They're essentially identical setups other than different contours. So let's review this first contour here. If I click on the edit button, you can see there are quite a few fields. First one is the tool selection. For this, I'm using an 1/8 inch 2-flute flat end mill. And on the next part, I will show you how to add a new tool since we'll be using a 1/4 inch bit on the next part. Okay, if we click on this geometry tab here, you'll see where I've selected this inner contour. You'll also see that I've added tabs, and that's to keep this center part from flying away while it's being cut. So I've added 3 tabs, and you can change the shape of the tab, the size of the tab, the number of tabs, and you can even manually position the tabs. So very convenient, and those can be easily cut off with a hand tool after the CNC router is done. So if we click on this Heights tab and reorient our part here, you'll see these blue, green, and orange lines. And these represent how high the tool gets lifted up between different operations. So if you're using things like clamps, for example, you'd want to make sure that these lines are high enough that when the tool retracts and moves to a different part of the workpiece, that it's high enough that it's not going to crash into your clamp. Okay, for passes, I selected these multiple depths and I decided to only go 40 thousandths of an inch at a time, meaning I would make several passes. And the reason I did that is, once again, this is a very small bit, and I'm just trying to figure out how much my spindle can handle at one time. Now, one of the great things is we can simulate our CNC motions here. We can set a speed and hit the play button and see how our tool will travel across our part. And if we want to see the entire setup, we can click on the setup, do the simulate again, and do the whole entire part. And I'll speed that up. For my next part, I wanted something quite a bit bigger, so this key will actually be about 10 inches long. Like I said earlier, I'm going to be using this 1/4 inch bit, which, as you can see, is quite a bit larger than this 1/8 inch bit. So that should allow us to go a little bit deeper and cut a little bit faster. So to make our part, the first thing we do is click on Manufacture here, and we will have to create a new setup. Next, I want the origin to be located over here at this corner. So I'm going to hit the select button, click on this corner. Now, if we rotate that a little, you can see that it is just how my CNC router is set up. The X is the long direction on my router, the Y is across, and Z is up and down. And you want your stock to be larger than your actual part. So I'm going to add an inch of offset to my part. And let's see, on the top, 0, bottom 0, round to nearest, perfect. Now over here it tells us that we're going to need a piece of stock about 12 inches long, 6 inches wide, and 0.65 inches thick. Now the wood I'm using is actually 0.63 inches thick, but I wanted this stock height to show just a little higher, just to make sure we get all the way through it. So if I click over here on my library, you see that we only have the 1/8 inch bit. We want to add the 1/4 inch bit. In order to do that, we click here on the plus sign and pick the right type of mill. For us will be the flat end mill. I'm going to type in a description, 1/4 inch, 2 flutes, end mill. Next, we click on this cutter tab to define our end mill. Ours only has 2 flutes. It is high strength steel. Our overall length is 2.5 inches. Below the cutter, we will have about 1.5 inch. The shoulder length is about 1 1/4 on this one, and the flute length is 1 inch. The shaft and holder tabs I'm not too concerned about, but this cutting data one, we might want to update this. Set a speed of 10,000 as our default speed. And I think I'm going to make this feed per tooth just a little bit smaller, which will give us a cutting feed rate of about 50 inches per minute. We click on accept and select our tool, and it's now loaded in here along with these preset values. Next, we want to click on this geometry tab, and we're going to select our contours. I'm going to start out by picking these 3 pockets right here, and we want to include some tabs. I prefer the triangular ones, but I do not like where they're located here. So we're going to maybe spread these out a little differently. I think I'll make these tabs just a little bit taller. Now here on our heights tab, we have similar ones to the ones I did on my last part. So I'm just going to leave those where they're at. Okay, on this passes tab, I think I'm going to leave everything as it is, except I am going to click on this multiple depths. Now it looks like there's a 3/4 inch depth step, which is much too aggressive probably for this machine. In fact, I'm going to be pretty cautious with this run and maybe go just 1/10 of that, which means it will take several passes. And here on the linking tab, I'm going to select this keep tool down toggle and then hit OK. So here we have a preview of what our stock will look like after the first contour operation. In fact, we can hit the simulate button here and play through exactly what's going to happen. As you can see here down in the pocket, we have our tabs that we asked for. All right, so our first operation looks pretty good. I'm just going to duplicate this first contour, and we're going to click on Edit. This will keep all the settings the same as before, except we will change our profile to this outer edge here. And I do not want tabs on this one because I think I'll have enough tape underneath to hold this thing down. So once again, we can simulate this operation. Looks good. We need one final operation to cut out this groove here, and for that we're going to use a 3D contour. You'll notice that it kept our original tool. We're going to come over here to Geometry and click Selection, and we're going to use a chain selection, Open Chain, and we're going to select our lines that we want to follow. So this, we're going to click here as well as here, and then click OK. We want the tool containment to be inside the boundary, and we want to contact the boundary points. Here on passes, we're going to make a maximum step down of 25 thousandths. That will just help the ramp portion be a little bit cleaner. And let's click OK and see how this looks. All right, so we click on simulation, play button, and it looks like it's doing what we want it to. Just for fun, let's run the entire setup. Click here on Setup 1 and hit the Simulate button. Let's watch the whole process. Now, because I'm still new to this and prone to make mistakes, I've clamped a thin piece of temporary wasteboard on top of my permanent wasteboard. Hopefully, as I gain some confidence, that step will become unnecessary. Now, to attach my stock here, I've added some painter's tape to both the wasteboard and the stock, and I will attach the two using a little super glue. So here's our stock taped and glued down to the wasteboard. Now, when we connect to UGS and the Arduino, it will assume that this current position of the spindle is the home position. And we will need to move it over here to reference the top corner of the stock, as that is what we did in our part setup. I just opened up UGS and connected to the Arduino. You can see these are all zeroed out to start with. Now I'll use the jog controller over here to move the spindle to my part origin. I have my X and Y in the position that I want, so I'm going to click X0, Y0. Now there are a few ways to zero your Z-axis. One is to bring the bit until it just barely touches the top of your stock, then hit the 0 button. The other way is to bring it down until it just barely touches the wasteboard, and then raise it up the known thickness of your stock, in my case 0.65 inches. I'm going to do the second way. Now I have the spindle lowered so the bit is just barely touching the wasteboard, and I've got a step size of 0.65, and I'm going to raise it up and then 0 my Z. Now back here in Fusion 360, we're going to click on Actions, Post to UGS, and we are going to select setup number 1 and hit Post. So as you can see, it dumped all of the G code here into this window here and dropped our part in. So all we have to do is hit this play button. And after a little bit of sanding and an application of Danish oil, the final product is looking pretty good. Just for fun, I threw some shiny paint onto my A. Well, that's it for this video, but stay tuned. I am sure we will see this CNC router again in future videos. As always, thanks for watching.